Numerical number 10, Kinematics 3. Numerical number 10. The velocity of a train increases at a constant rate alpha from 0 to v and then finally decreases to 0 at a constant rate beta. If the total distance covered by the particle be x, then show that the total time taken by the train will be t equal x by v plus v by 2 bracket open 1 by alpha plus 1 by beta. We can draw velocity time graph. Velocity of the train can be plotted along vertical axis and time interval t can be plotted along horizontal axis. Now we can draw velocity time graph for the motion of the train. From this straight line is velocity time graph. From O to A, train travels with the certain acceleration. That's why the slope of the curve or the graph is positive. Then from the point A to B, the train travels with uniform velocity. That means the train travels with zero acceleration. Then the velocity of the train decreases, means from the point B to C, the train travels with retardation, with certain retardation. From the point A, we can draw a perpendicular on time axis, and that perpendicular is AN. AN is a perpendicular drawn from the point A on the time axis at N. The time t is equal t1 second. At A, time t is equal t1 second. The velocity time graph OA, that is the straight line OA, makes an angle theta with the positive time axis. Similarly, we can draw a perpendicular from the point B on time axis, and that perpendicular is BM, and at M the time t is equal to t1 plus t2 second. Time t is equal to t1 plus t2 second, and the velocity time graph, that is the portion BC of velocity time graph, makes an angle phi with the negative time axis, and also at the point C, t is equal t1 plus t2 plus t3. At the point C, t equal t1 plus t2 plus t3. According to the question given, t1 plus t2 plus t3 is equal to t, and S1 plus S2 plus S3, sum of distances travelled by the train is x. Total distance travelled by the train is x, and we have to find the time t equal question mark. S1 is the distance travelled by the train from A to O to A, and S2 is the distance travelled by the train from A to B. Then B to C, the train will traverse a distance S3. So S1, S2, S3 are the three distances travel by the train in time interval t1, t2 and t3 second, and the total distance covered by the train, when it accelerates with the rate alpha, or at a rate alpha from the point O to A. The distance covered by the train when it accelerates at a rate alpha from O to A is given by S1 equal area of right angle triangle ANO, which is equal to half into perpendicular into base. AN is the perpendicular, ON is the base. Half. Now putting the values, now at A we can draw, from A we can draw a straight line parallel to time axis, the point at which this straight line from A touches with the velocity axis, V will be equal to Vmax, and according to the question, maximum velocity of the train Vmax is V, and the length of the straight line in is Vmax, which is the maximum velocity of the train. In place of AN we can write Vmax, which is the maximum velocity of the train. ON is what? T1 is the time interval or time taken by the train to travel from the point O to A for a distance S1. This is maximum velocity of the train, that is the length of the straight line AN is V max. So S1 is equal to, putting the value of Vmax which is equal to V, we get S1 as equal Vt1 divided by 2. S1 is equal to Vt1 divided by 2, which is equation 1. S1 is the distance traveled by the train from O to A, between which the train accelerates at constant rate alpha. Similarly, distance traveled by the train from the point A to B, distance traveled by the train from the point A to B when it moves with uniform velocity. It moves with uniform velocity Vmax equal V from the point A to B in time interval t2 second is given by S2 will be equal to the area of rectangle ABMN, which is equal to product of two sides, that is AN into NM equal Vmax into T2. Therefore, S2 is equal to V into T2. S2 is equal to Vt2, which is the distance traveled by the train when it moves with uniform velocity V from the point A to B. S2 is equal to Vt2, which is equation 2. S2 is equal to Vt2, which is equation 2. To prove total time taken by the train T as equal x by V plus V by 2 bracket open 1 by alpha plus 1 by beta. The term V by 2 into 1 by alpha will come for the accelerated motion of the train, and for the term V by 2 into 1 by beta, we should consider the motion of the train with retardation, and for the term x by V, distance divided by V, we should consider the motion of the train with uniform velocity from A to B, and for 1 by alpha we should consider the motion of the train from O to A, and for 1 by beta we should consider the motion of the train from the point B to C. Similarly, the distance covered by the train, when it decelerates with constant rate beta from the point B to C is given by S3, that will be area of right angle BMC. Area of right angle triangle BMC, that is S3 is equal to half perpendicular BM into base MC, or comma S3 is equal to 1 by 2 Vmax into T3. T3 is the time interval in which the train decelerates, and finally we get S3 as equal Vt3 divided by 2, Vt3 divided by 2, which is equation 3. Therefore, the total distance traveled or covered by the train, from the point O to A, then A to B, then B to C is given by S1 plus S2 plus S3, which is equal to Vt1 by 2 plus Vt1 by 2 plus Vt2 plus Vt3 by 2. Vt2 plus Vt3 divided by 2, or comma x is equal to, or comma in place of S1 plus S2 plus S3 you can write total distance x as equal Vt2 plus V by T under bracket T1 plus T3, V by T, V by 2 plus under bracket T1 plus T3. So we get x as equal Vt2 plus V by 2 bracket open T1 plus T3, or comma x is equal, putting the expression of T2, and now V is also taken common, x is equal V bracket open T2 plus half T1 plus T3, or comma x is equal to, or taking v on the left hand side, we get x by v as equal t2 plus half t1 plus t3. X by v as equal t2 plus half t1 plus t3. T1 plus t3, which is equation 4. The acceleration of the train from the point O to A while traversing a distance s1 is given by, the acceleration of the train from the point O to A is given by alpha equal tan theta, where theta is the angle subtended by the velocity time graph OA with positive time axis, which is equal to an by on, which is equal to Vmax by T1. Alpha is equal to, or comma alpha is equal to n by on, or comma alpha is equal to Vmax by T1. Therefore, T1 is equal to V by alpha. T1 is equal to V by alpha, which is equation 5. T1 is equal to V by alpha, which is equation 5. Again, the retardation of the train from the point B to C. The retardation of the train from the point B to C while traversing the distance s3 is given by, the retardation of the train from the point B to C is given by beta is equal to tan of 180 degree minus phi. Tan of 180 degree minus phi, that will be equal to tan phi. So that is beta is equal to Bm by mc, perpendicular Bm by base mc, and at the point in the time t is equal to t1 second, or comma Bm is equal to, putting the values of Bm and mc, we get V by t3, or comma t3 is as equal V by beta, t3 as equal V by beta, T3 as equal V by beta, which is equation 6. Now T2 is equal total time interval T minus T1 plus T3 equal T bracket open V by alpha plus V by beta. We get T2 as equal T minus V by alpha plus V by beta, which is equation 7. Using equations 7, 6, 5 in equation 4, using equations 5, 6 and 7 in equation 4, we get x by V as equal T2 plus half T1 plus T3, or comma x by V, putting the expression of T2, T1 and T3, we get T minus V by alpha plus V by beta plus half V by alpha plus V by beta, putting the values of T1 and T3, or comma x by V as equal T minus half bracket open V by alpha plus V by beta, or comma T as equal x by V plus half plus V by 2 bracket opened 1 by alpha plus 1 by beta. We get the expression of total time interval T, which is equal to x by V plus V by 2, 1 by alpha plus 1 by beta. And this is the total time in which the train travels from O to A, then A to B, then B to C. This is the time taken by the train to cover a total distance S, total distance x. This is the time in which the train travels from O to A, then A to B, then B to C with constant acceleration, then with uniform velocity, then with constant retardation. Hence, this expression is proved.